There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guests on this episode of Blue Blazes are Steve Sanderson and Javier Calvarro Nelson, who both work on Blazor, a .NET Web UI framework from Microsoft. Before creating Blazor, Steve was known for creating Knockout.js. He's currently a developer and architect on the .NET team at Microsoft. Javier is a principal software engineer at Microsoft and has helped build Blazor since its introduction to the .NET ecosystem. In our conversation, we discuss what Blazor is, how it enables building web UIs with .NET, its different modes of operation, and how you can use it to build both modern web and cross-platform apps. It's a fascinating discussion with two very knowledgeable people, and I'm excited to share it with you. Well, welcome to the podcast, Steve and Javier. Nice to have you both.
Hey, thank you.
Good to see you today. So we're going to be talking about Blazor today, which I know you both know quite a bit about. Maybe Steve, since you've been around since line of code 1 on Blazor, maybe you could give me the elevator pitch for what is Blazor, for maybe if there's someone out there who still hasn't heard of it or isn't familiar with it.
Sure. Well, Blazor is a web UI framework for .NET. That's really the truth of it. That's everything that it is. So it tries to cover a bunch of different usage scenarios. So it covers both fully isolated and potentially offline client-side applications when running on WebAssembly in a browser. It covers server-oriented programming, both in terms of traditional request response type HTML programming and a WebSocket-based live interactivity mode. So it kind of tries to cover all the possible or sane ways that you might build a web application and give you a single programming model that works for all of them.
Okay. So you mentioned something in there that will be, I think, important for people to understand to know Blazor, which is WebAssembly. Javier, you want to maybe give the quick what is WebAssembly?
Sure. So WebAssembly is a standard technology that ships in browsers for a few years now. And essentially, it allows you to compile programs in other languages and run them inside the browser alongside your JavaScript. So that is what allows us, for example, to run .NET in the browser via our own WebAssembly runtime, and is what powers Blazor under the hood. And that isolated experience of .NET apps running on the browser that Steve was mentioning about.
So when Blazor first came out, it was experimental, and it really just ran in the browser using WebAssembly. Since then, it's been a few years, and there's been quite a few different modes that Blazor can run in. Either one of you want to take this question? What are the different options now for where Blazor can actually run, or the different modes that it can run in?
Sure, I can take it if you want, Steve.
Go for it.
Sure. For start, the first version of Blazor actually ran on the server. Blazor WebAssembly came in like a bit later. But essentially, Blazor can run on the server entirely. Your app runs on the server, and you only receive updates via a WebSocket with Blazor server, or you can run completely on the client with WebAssembly. And the mode that we added in .NET 8 was the ability to build more traditional request response apps with Blazor Web, which added server-side rendering in the traditional sense, like MVC or like SP.NET web forms. And finally, we also have the ability to run on mobile devices via MAUI. And I think that's it.
Yeah. And there's also this more recent addition of an auto mode, which kind of allows the framework to choose. Steve, could you talk about that a little bit?
Yeah, that's right. So in .NET 8, when we added the ability to do request response type programming, we decided that we didn't just want to keep all these modes separate from each other. We wanted to make them all work as part of a harmonious system. It was unmanageable to have so many different modes and expect people to just choose one time at the start of their application building process. Like, how does my thing work just forever? Make sure you get it right because you can't change it later. Like that wasn't how we wanted things to work. We wanted to make it flexible so you can easily change between different modes and you can use multiple modes simultaneously, things like that. So that was one of our key goals in .NET 8. And a sort of side benefit that we get from that is the ability to make this decision so late that it actually happens at runtime, based on the scenario at hand. Like when a given visitor comes to your site, we can decide at that exact moment what's going to be the best mode for them. Is it best for it to run on WebAssembly in their browser, or is it best to run on the server over a WebSocket connection? And we could make that decision on various different grounds. Like we could do it based on like how fast is your CPU or how good is your network connection or whatever. What we did in .NET 8 is a relatively simple built-in rule, which is just if you've already got the WebAssembly stuff cached locally, then we'll use that. And if we haven't, we'll use the server mode while we're downloading the WebAssembly stuff in the background. So that form of automatic switching is what we call the auto mode. And it's intended to produce the benefits of both, really, because you get the instant startup of server if you haven't got the files cached already, and you get the minimal server resource usage of WebAssembly if you have got it cached already. So that's what the idea of that is. Now, I will also add that it also adds some additional complexity for the developer. So, in software, you don't get any good things for free. Like as a developer, you've got to handle a bit of extra complexity if you're going to do this, because you now have to deal with the fact that your code can run in two different environments. You can't just assume it's running on WebAssembly or on server. And even though we try to keep the programming model as identical as we can between those two things, there's still some fundamental differences. Like when you're on the server, you can just access your server-side resources directly. If you want to make a SQL connection to a database, you just do it. You certainly can't do that from inside a browser for security reasons. So, there are differences between how your code is going to behave in these two environments. And so if you're going to switch automatically, you have to make sure you've accounted for both possibilities.
Makes sense. Like any technology or tool, it's important to understand a little bit about how it's working under the covers. Otherwise, if you just set everything to auto mode, you're going to be making lots of mistakes. Yeah. Okay. So I always find that when people I'm talking to are first hearing about Blazor, that they want to kind of file it away into a category in their head. And I think it probably does not compare directly to anything else that exists, or it compares to a whole bunch of different categories. So I'm curious, since you're both on the team, what do you think? What do you think of as kind of your main competitor or comparable frameworks that are out there that are doing anything similar to Blazor?
Javier, do you want to do this?
Sure. So that's an interesting question because with Blazor, we try to be a bit of a jack of all trades in the sense that, as we said, we see ourselves as the way of writing web UIs using .NET wherever you want to deploy those web UIs. So that means that we obviously have competitors among other popular frameworks, React, Angular, Vite, and so on. But we also compete with things like, well, not React Native, but in the sense that it's not really web UI, but in the sense of we are on the same mobile space. So kind of like React and other frameworks, they kind of work on the web and they also have like a mobile story or a native story. we are pretty much in that same bucket. Our main focus in that sense is web UI. So our competitors are not maybe, how is it called? This thing that is so popular from Google. I can't remember the name of the technology.
Flutter?
Flutter, yes.
Yeah. Gotcha. Yeah, and I think that's interesting. In your answer, you listed a bunch of different technologies that are all accomplishing different types of things. And we haven't talked about this yet, but you mentioned some mobile technologies like Flutter there, and we've been talking pretty much about web story so far for Blazor, but there's also a mobile and even a desktop story for Blazor. Steve, you want to maybe cover that a little bit?
Yeah, sure. So when people build native applications for mobile or desktop, one of the main decisions they need to make is, do they want to use native UI elements, or do they want to use something cross-platform? And, it's a classic trade-off here. Native UI tends to feel more natural to the users of a given operating system, but it increases the costs of development potentially manyfold. If you had to build a single application to make it work on Windows, Mac, Android, and iOS, and have it use truly native UI for all of them, you're just going to be doing 3 times or 4 times as much work, depending on how complex your UI is. So it's very common that people want a cross-platform UI story. Flutter is a way of doing cross-platform UI without using web rendering, and that's been fairly successful. But I'd say the single most successful cross-platform UI technology by a pretty enormous margin really is Electron. And, this is using web-based programming. It's using web rendering, and a very large portion of desktop apps are built this way now because developers just find it's a good trade-off of the amount of work that they put in and the cross-platform reach that they get, especially ones that have got a web background and already know how to sling some CSS and get things to look how they want. So Blazor is yet another way of doing that. If you want to use .NET and HTML as your way of doing desktop or mobile programming, then Blazor running on top of MAUI is our solution for doing that. MAUI is a cross-platform .NET UI technology that abstracts over native UI. And if you just want to do some HTML and CSS in that, then Blazor for MAUI gives you that capability.
Well, that's really powerful, and goes back to Javier's earlier point that in a large sense, Blazor is kind of a jack of all trades, especially in these recent releases like .NET 8. So I'm curious a little bit. Again, another kind of question for you on the team. How do you think about who your primary audience is for Blazor? So what I mean by that is, I'm a MVP for 10 years. I'm a big .NET fan. So you don't have to convince me that building stuff with .NET is good and fun and easy. But if as a consultant, if I had a team full of web developers that wanted to build a mobile app, I might push them in React Native or Ionic direction, for example. If I had a team of C# developers, I might push them towards .NET MAUI for building that same mobile app. So a little bit has to do with experience and some other factors. How do you guys think about who's the audience or audiences for Blazor?
I would say primarily it's .NET developers for sure, because the value proposition is very strong. If you have got a .NET background, then being able to use that for your UI and not having to go and use Swift on Mac and JavaScript in the browser and so on, and all these different combinations for different operating systems, just using one technology and specifically the one that you already know well is an extremely strong proposition. So that's certainly where the majority of our users are. In terms of appealing outside of that audience, I think you can't really separate Blazor from the .NET. I don't think it would make sense for us to go to some, let's say some Python developers and say, hey, use Blazor because it's a great UI framework and just tell them about the UI thing. Like what we would really be having to tell them about is .NET and C# and the whole ecosystem around NuGet and all that kind of stuff, because that's 80% of what you're dealing with. Blazor is giving you the UI layer on top of that, but we can't really, you can't sell or convince people of a UI layer on its own without also convincing them the entire kind of like mountain that they'd be standing on in order to do that. So yeah, I see it as being part of the overall proposition of .NET and what makes .NET appealing, in that it's so flexible. You can use it for web programming, you can use it for games, you can use it for low-level systems programming, you can embed it into all kinds of things. Like it's an enormously broad reach, and having a strong web UI story is an essential part of that. So that's the role I see Blazor playing in this sort of overall goal to make .NET do everything for everyone.
Yeah, so if you're starting from I want to build UIs, maybe web technology-based UIs, but I want to do it with C# and .NET, that's really your prime audience.
Yep.
That makes sense. So with any technology with web applications that is potentially running on the server, on the client, a mixture of both, like the way Blazor can, you run into some technical challenges. Steve, you alluded to one of them, which is security. So making sure that secrets stay on the server side. SEO is another challenge sometimes with these types of applications. Javier, could you talk about how either of these issues or other types of issues similar to that are addressed in Blazor either now or in the future?
Sure. So let's start with SEO because it's an interesting one. The main comment about SEO that you get when we are talking about SPAs are that they run on the browser and the crawlers can understand JavaScript and so on and so forth. So the first thing that one of the things that we added in .NET 8 was the ability to do server-side rendering in a more first-class way. So that means you can always pre-render your app. And even if the crawler didn't understand JavaScript, which, by the way, it does, you would get, the crawler would get to see all the page, and you would get to do the fast loading time for the static document and so on to get all your CEO in place. And the second one with security is an interesting one. And in that sense, Blazor Server, for example, is a great flavor of Blazor because it allows you to keep all the security on your server. You don't have to be dealing with tokens or HTTP requests or anything like that. You don't have to have APIs exposed to call your database and so on. Everything can happen within the app. And that definitely brings an extra layer of security to your environment.
Yeah, okay. What about state management in Blazor? A lot of JavaScript frameworks either have built into them some sort of state management, or there's a lot of popular libraries that you can bring in to the ones that don't have it built in. What's the state management story for Blazor?
There are state management libraries for Blazor. We, as a team, don't provide one out of the box because we don't think we should have an opinion, or we don't currently have an opinion on what's the best way to do state management. And it's one of these things where the community has already provided several solutions. There are several ports of famous patterns and famous libraries from other ecosystems like JavaScript, and people is happy with it.
Nice. Can you name any of those off the top of your head, Javier?
I think there is Fluxor, which is Flux for Blazor. And yeah, that's the main one that I think I can recall from the top of my head.
All right, good. Yeah, that way anyone listening can maybe look into that a little bit more if they're interested. So let's talk a little bit about scaling. So let's say you're trying to build a Blazor application, but you don't want to build it for hundreds of thousands or maybe millions of users. What considerations do you need to keep in mind as you're doing that?
Well, different approaches to deploying and hosting will impact scale considerations quite considerably. Generally, you could look at the traditional HTML request response approach being probably the most sort of having the most well understood scale characteristics. That's the way that web apps have been built for literally decades, and people roughly have a sense of, I just need to stand up enough servers in order to cope with enough responses and maybe put a caching layer on in front of it or something like that. And so all of those traditional approaches apply with Blazor server-side rendering. People have a slightly harder time reasoning about the other approaches there. I think in the case of WebAssembly, it's relatively straightforward as well, because the cost of serving the static content for your WebAssembly to browsers is usually very low. Even if the content is big, like megabytes, it's still, just firing bytes over the wire that you didn't cost you anything to generate when the request came in. And again, you can have a caching layer in front of that as well. But then you have to start thinking about the scale of your backend APIs, because you don't just serve static UIs to people. It has to then start talking to backend services. And so now you need to think about that. But at that point, it's not really a web UI question anymore. I think the one that people have the hardest time understanding is the Blazor server or WebSocket-based model, because they have less experience with it. And I would say it's absolutely true that you can, if you want to, or if you're not careful, you can consume a lot of server-side memory per user by doing that. So the way Blazor server works is that all of the state associated with a given user is held in server memory. And if you can imagine that they had some kind of list editor. If you didn't put any limit on how big the list could be, somebody might, add billions of items to their list. And then all that's just being stored in server memory. And if you've got, tens of thousands of users doing that simultaneously, then perhaps you're going to hit some memory limitation. In practice, it tends to not be an issue in most cases, because for one thing, .NET doesn't have a lot of overhead over, the way that objects are stored. The amount of state that most applications are storing per user is just going to be like some hundreds or thousands of sort of human readable length strings and numbers and so on. And that probably represents all of the state for a user. It's probably going to be a negligible amount of memory. And out of the box, you're probably going to get, tens of thousands of concurrent Blazor server users on a single modest-sized server. And as much as developers love to believe that they're going to get millions of users, most applications do not exceed this, 10,000 concurrent users level. But yeah, in the event that you do, you would want to have multiple servers, and you start scaling out through traditional methods like that.
Yeah. The other thing that I would add is that if you have any sort of scalability problem with Blazor server, because you're using too much memory on the server or something like that, you would have probably that problem even if your app was request response based, because nothing prevents someone from hammering your endpoint with and forcing you to create a list with 1 billion items.
That's true. Any application can have performance problems. Absolutely. Well, this will be published just shortly before the release of .NET 9, this podcast, and lots of great stuff coming in .NET 9. I wonder if you could give a little bit of a preview of some of the things that you're planning on having ready for Blazor for .NET 9.
Yeah, Javier, do you want to take this? You've been a development main dev on this one.
Awesome. Yes. So for .NET 9, we've focused a lot on the internals of Blazor and paying some of the technical depth of all the releases that we have so far, and improving a lot of the way things work. In terms of performance, we've done improvements in startup time in WebAssembly, and I think it's 20% or something like that faster to boot a WebAssembly app right now. We've also added compression to WebSockets, so that makes Blazor server much more efficient. And again, you get the same benefits of compression. We've expanded some features that were part of Blazor that are now available for all ASP.NET. Like, for example, work that we've done in optimizing static assets. That means that now all your files get gzip and broadly compressed to the maximum level during build and publish, and they get served with efficient cache headers. One new thing that we added recently is fingerprinting. Fingerprinting is this technique where you create a unique URL for a resource, and that allows you to tell the browser, hey, this resource never changes. So that also goes a long way to speed up recurring visits, because the browser doesn't even have to, in many cases, make another request to get those files again, or to check if those files are even have even changed. And then we did a bunch of other stuff. For example, we added support for detecting the server the render mode that your component is in. So you can now make decisions at runtime on your component based on whether you're going to be rendering WebAssembly, or you're going to be rendering server, or you are just rendering statically. So that allows you to, for example, produce a markup that gracefully degrades if you are running statically to, for example, handle a form, and so on. We added support for small things like constructor injection. We improved a bunch of the default UI on the templates, and I think that's that's mostly. I'm sure I'm missing a few things, but
that's a pretty good list. So with those performance improvements, the caching and compression and startup time improvements, it sounds like stuff that somebody who's got a Blazor app already is just going to recompile and get a lot of these performance improvements for free.
Yeah.
And
and in this case, not just Blazor, MVC also.
Oh, nice. Okay. Those are the best kind of framework updates, because then everybody's the hero at their place of work. They now just recompile and they just made the application a whole bunch faster, thanks to all your hard work, right?
Yeah,
that's awesome. And also, I feel like it fits into the theme of the updates to .NET in general over these last several years, where performance is truly a feature. So thanks for doing all that. That's awesome. So obviously, when this comes out in October, we'll be getting close to the release of .NET 9 and also to .NET Conf. So that's probably a pretty good place where people can find both of you, I imagine, and a lot more information about what's new in Blazor. What other resources would you point people to if they're looking to get started in Blazor?
Well, we've got a bunch of good sample apps. We've got, hopefully, all the documentation you're ever going to want on this. And I'm sure we've got a nice sort of getting started webpage, but I don't personally remember the URL of it. I'm sure I can find out the URL, and perhaps you can include it in show notes.
Probably learn.microsoft.com, something.
Yeah.
Okay. So they can search on the Learn website, I'm sure, and find that stuff. Any YouTube content people can find out there getting started?
There's definitely a lot of it, but we've been doing this for a long time now. Blazor's been in sort of supported mode since 2020, and it's been doing previews since 2018. And during that entire time, we've just produced content for things like YouTube. So there's going to be a massive back catalogue of that.
Awesome.
I don't know what the current sort of best getting started point is, but I'm sure that if you can find the sort of Blazor homepage, it'll link you to something good.
Sounds good. The last question I like to ask all of our guests, and I'll ask both of you, and if you both have a different answer to this, that's great. If just one of you does, that's fine too. But the question is, we do this podcast about making software projects more predictably successful, and I'm curious what other topics or guests we should have on the podcast in the future. Any thoughts on that? Javier, you want to go first?
Sure. So I think Aspire would be a good topic in terms of modern development, especially for microservices architectures and these things that are now in fashion these years.
Yeah, I see a lot of stuff going on around Microsoft with Aspire right now. I'm sure there'll be lots of announcements there with .NET 9 as well. So that's a good one. Steve, anything to add to that?
Yeah, well, we've been talking about WebAssembly a little bit. I think that across the industry, not just in Microsoft, but people are doing a bunch of interesting stuff with WebAssembly, and they're trying to use the isolation of it to create this sort of like ultimately predictable environment for software to run inside, which really aligns with your topic quite well. There's been various efforts to use WebAssembly as a general server-side programming environment. So I think it would be very interesting to dig into Wasm Cloud and Fermion. They're two startups that are both building server programming environments in WebAssembly, and I'm sure both of them would love to talk to you and give you some ideas about how that could make more predictable web programming in the future.
Yeah, that sounds very interesting. Well, thank you both for those suggestions, and also thank you for your time and expertise on Blazor. And Javier, thanks for all the work you put into making everyone else look like a hero with performance in Blazor.
Thank you.
I appreciate your time today.
Cool. Okay.
Cool.
Bye.
Awesome. Bye-bye.
That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one, with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.